No, I guess zoom enters that properly. Let me reduce that. So hi Tony, hi Matt. The suggestion I made to Matt was to roll actually the slideshow even for us, so that we share the knowledge between us of what's happening in the hydrodwig. And Matt will keep us then updated on what's going on in the UK side. So the agenda, yes, is I picked for the first point, I picked some elements of that I deemed were worth sharing since the last time the group touched base, with a specific focus also on the water quality interoperability experiment that I've been running since 2022. Introduction of two research projects I'm running in France and Europe, and Matt also has one on experimental research catchment data sets. So I won't go through what we have this group with you guys. You know why? So the first element I was willing to share with the group was the fact that we managed to finalize the review of observation measurement into observation measurement and sample. So it was quite a long process, almost 4 years. And between OGC and ISO, and now we have this new version where we also emphasize on the fact that they are samples that are modeled in the standard, how to collect samples and stuff like that. It was there before, but it was important to just emphasize on that. So given that actually that this overall presentation was a more kind of a compendium of what happened, I gave a lot of external links for people, for you guys to dive in if you want to see more. So I just picked 2 slides from the presentation that was in reference before. We've added several elements that do come from SOSA, nice W3CS and SOSA ontology. At the right side of the slide here, the fact that you can describe your observation system with a host where you would deploy observer. In many cases, observer would be sensors, but we on purpose not reuse the class sensor and from SOSA as is. We will rename that into observer because, like in BioDiv project, for example, observers can actually human beings that do observe biodiversity and stuff like that. So, but at the same 3-layer approach, and we have a lot of related observation and stuff like that, and that are the same. It's not detailed in that slide, I guess. Yeah, not on that conceptual level, but in the other layers of the models, we also clarify the feature of interest association between proximate and ultimate feature of interest, because there have been 2 different usages, so it was better to clarify. And we also polished a bit the notion of sampler that realize the act of sampling, that generates samples, and all that stuff. And that's this part we're making an important use of in the water quality IE. That's the first element. The second one was I was willing to also give some focus on the use of SensorThings API. In many organizations, we've seen various presentations actually in the hydrodynamic working group meetings over the last years of organization making use of SensorThings API. So to bootstrap people with SensorThings, I gave the link to the standard itself, a mention of host implementation as a reference, but not the only one. It's a really good open source reference implementation of the standard. Showing the fact that we now have the QGIS support for SensorThings natively on track as well. So you can connect QGIS open source GIS to a SensorThings endpoint and start actually acquiring observation and plot time series. So that's, for some elements, that's quite a small challenge in a way, because standard GIS tool of like the one table flat view of the world, and obviously when you load an observation, that's a bit more structured and time series and stuff like that, but it's really interesting and useful. So when I say native support, it means that there is a SensorThings data provider in QGIS, the same way you have a WMS or WFS available. So it's not a plugin, it's really core within QGIS, and what will remain plugin is more the graphical user interface side. But that makes sense. And we managed to have SensorThings API validated in Europe as a compliant download services for observation data. So that helps also tell people what to use. Before we, in the former European guidelines on observation, we were advising, giving guidelines on using sensor observation services. But now we tend to advise people to use SensorThings API. So then also I gave the link to reference, not reference, example presentations. There was I guess, yeah, the first one was about various inputs on the hydro community in Europe using SensorThings. And the other one is it's something we're doing in France with Oscar Research Infrastructure, and also using SensorThings to fetch and share observation data, water observation data in that research infrastructure. And we built from that dynamics in the water quality, i.e. interoperability experiments. I will mention right after. And I took some screenshots that are actually coming from an NSC presentation I gave last week that introduced people about this simple SensorThings API data model, the fact that you can actually also go down to really fancy queries, but also really simple one. It's really powerful. And this is an output, the top one image is an output from a joint project we had in Europe, in that case between France and Germany, sharing surface water quality data using that technology. That was a project that led also to validate it as an Inspire valid observation service. So yeah, SensorThings API is quite doing its nice move in the community, and not only in water. I mean, I have example in marine environment, in agronomy, and other domains. The third point I was willing to share as well is the fact that if we go on the ontology side of things, SSN SOSA is being updated currently. One of the main trigger is actually the fact that observation, measurement, and sample was finalized. So in order just to keep things aligned, the idea we have with the group is to have this SSN SOSA update provide the canonical ontology of what is in OMS, because OMS was modeled in UML as ISO was mandating the use of UML, not allowing us to do ontologies. So that will be the ontology. Of course, there are various alignments modules that are being updated, and we're handling various change requests that were kind of coming from the previous version. The group is now having weekly meetings. We're targeting hopefully an update end by the end of this year, and that's now quite an active group. Simon Cox is back, leading it on behalf of GEC activities, and we're various contribution. There is now a really nice momentum on this one as well. And the third part I was willing to report the group to was the fact that in Research Data Alliance, there is this I-adopt ontology for observable properties. And we have several actions to better align, connect, entrench, I don't know which word to pick, I-adopt with the various standards I mentioned before. Now we have a presentation next Wednesday with the I-adopt team on the RDA VP22. Where we will present some of the things, and that is for my part. I will be presenting how we link I-adopt to observation, measurement, and sampleological model, because you know that in ONM, OMS, it's the same. The observable property is just one class, and IADOP goes way further down that road. So how do we link that? There have been prototyping and some extra work on how we could add an extension to SensorThings so that also the observed property and the SensorThings side is described with further details. And the third bullet point is about how we have the same thing, finer grain observable property description in SSN SOSA. And we haven't yet finalized the decision, but there is a high chance it's not in the core of SSN SOSA, more as an extension. But yeah, it's really worth sharing that. That's it. That's what comes from. No, there was also the feedback on the two big workshop we had in 2022. One were an L2 workshop and the one on water quality. But I don't know if you, Matt, were aware of that, but I guess Tony was already aware of those one.
I knew it was going on. Yeah, I wasn't involved.
Okay.
Some other things.
You have questions so far, or you want me?
No, that's really helpful. No, it's really good to see. Well, it's good and good that you're working with that iAdopt group as well. It's nice.
Yes, and actually, I had a web conf last week with Barbara, and she's also planning to invest kind of fine grain description of the observable observation procedure as well now. I mean, that's kind of also anticipated. And what we're doing actually in SOSA currently is discussing how to link observable property and their procedures directly from the model. Because so far, what we have as let's say, so SSN SOSA is it's the observation that connects the property and the procedure. Because you say, I've used that procedure to observe that property. But in many systems, you actually can know before you receive observation what is the list of allowed or authorized or mandated procedures for given a set of properties to maintain registries of such properties and procedures. So we are adding those extra links in SSN SOSA. There is movement there. Yeah, so I was also planning to have a longer introduction to what has been running since September 2022. So it's the water quality interoperability experiment. For the sake of that very presentation, I just grabbed 4 or 5 slides from that presentation that is mentioned below as a reference. So Dave Blodgett asked me to present the water quality IE at the NSIP Foundation session last week. So if you guys want to see the full 1-hour presentation, is there. And I saw that the HydroDweek Twiki was down at the end of the day, but my plan was to push that presentation, both presentation actually, to Twiki for people as well to have more background. So yeah, so we launched the water quality IE in September 2022 after the water quality workshop that is mentioned in the previous slide. Everything starts from that reference point, from that GitHub, and then the GitHub home page README Markdown dispatches people to the rolling mini document, the modeling stuff and stuff like that. So if there is something where to start from, is that thing. I will go through that cascade, like what are the use case, what did we model, which API do we pick, and which implementation, but in a really short fashion. So the use case we've identified with the group were the following, and we grouped also the water types all together. So we, in that table, the surface and groundwater are grouped together because the discussion was valid for discussion for both of them. So we concentrated on physical properties, like in situ observation of conductivity, for example, also chemistry, be it on field, but also in the lab. Biology was tag number 3. Okay, biology is mainly valid for surface water, but it was out of scope of this IE just for the sake of the fact we cannot be everywhere. And I mean, we need to start somewhere. And we said also hydro models and remote sensing were not in scope of that, i.e. at some point we wonder if we'll see when we land, but maybe there is a chance we might have an IE number 2 on the topic. So we focused ourselves on physical properties and chemistry. We had to deal with quantity, surface and groundwater quantity, as I was saying to Matt before the other joins, especially given that Water and Water2 Part 1 time series was written 15 years ago, something like that, 2009. And since then, O&M moved to OMS, were less and less using sensor observation services, more SensorThings and stuff like that. And water quantity is kind of required if you want to do quality. So that's why it's also in the table. And then for each use case, we've been doing that cascade. So discussing with taking into account the diversity of people on board. Not everyone was kind of accustomed to O&M, SensorThings and stuff like that. That was part of lowering the entry ticket, so kind of doodling your domain objects and for people to have a common understanding. Then moving to actual modeling. And when the group was clear on what we meant by which term, what was a water quality station, for example, or time series, stuff like that, which API to exchange what, and then implement. And we're currently at the implementation phase right now. So I haven't given much example in the slide, but obviously the UML models are based on OGC and ISO standards. So I should have listed there, but we're mainly working with OMS, with groundwater ML2 and hydro features. That's mainly what we're using. After a lot of iteration, we ended up by realizing we really have just 2 modeling patterns. All that is in situ, be it in situ quantity or in situ quality, is following the same modeling pattern, I would say. And what is ex situ is following a second one, so bit richer one. So I just gave an example for the in situ one. This one is groundwater. In situ quantity, but again, it's still valid. It will be exactly the same one if we stick to groundwater here for the groundwater quality, a part that you would point to different code lists here. So we have situation where so what we use also, to land and to guide people into how to use standards. Everything was covered in the standards, and actually I should have written that in slides. 99% is in the standards, so it's more a matter of documenting how to use it. No need to create new classes. So we went through a lot of object diagrams. It's another UML schema that is not so used, but actually it's really good for communicating how to use a standard. So this one, not just kind of hide the classes in UML, but we have a well where you deploy a sensor using OMS terminology. Those well and sensor to declare what called observing capability in OMS. It was not in ONM. It's a grab from Inspire, this one, in observing capability. So it means you declare what you're doing actually before you can declare even without having actual observation. So your sensor claims, I'm monitoring like, I don't know, a groundwater level through that type of procedure. I'm monitoring groundwater so here I'm on quantity, but if I were on quality, I would say I'm monitoring groundwater conductivity using that other procedure on that, of course, the ultimate feature of interest. So here that will be the code of your hydro unit. It's for the left part, and for the right part is hey, I've acquired data result, observation, timestamp, and all the stuff. A precision spatial sample. I haven't taken that as a slide for that slideshow, but then of course you can group the observation by collections. That's a new concept in OMS, and then your observation collection is obviously a time series, and we have the good old time series pattern. That this one, and this one is for ex situ. It's of course a bit involving a bit more classes. The cornerstone is like the act of sampling. sample a water body at some location that correspond to water quality station. And your sampling generate what is now called in OMS material sample. That's the field of water you want to take to the lab, and then on which you will carry out observations with a procedure observation, and we have the result. I have not taken a more complex one. I have another example on groundwater where we actually subsample the sample that is here. It's of course supported by OMS, and you have that in many situations. For example, the one we have on groundwater is arsenic concentration. You need to stabilize that before it reaches the lab. So it's a subsample with some preparation step, and everything is covered in the standard as well. So we have those patterns, and what we've been doing then is moving from conceptual modeling to how do we exchange that in an API. So starting from SensorThings, we've enriched SensorThings model for two reasons. The first thing is that SensorThings model 1.1 is based on ONM. And as I said in the introductory slide, we now have observation, measurement, and sample standards. So we needed anyway to enrich SensorThings so that it's OMS compliant. So all the classes in green are actually classes that allow SensorThings, future SensorThings 2.0 to be OMS compliant. So we added that deployment to allow to have the same trinity as we had in OMS, like your host, deployment, and observer. We gave true reality to the observing procedure because in the community you had people using sensor to either describe their sensor type or sensor instance, so it's the wrong mixture. So here you will describe your observation procedure, could be sensor type, and here you will be the actual sensor with a serial number using the observation. Those class allow SensorThings at the bottom here allow SensorThings to actually describe observation that are based on samples, which was not the case before. And we refined also the feature of interest part so that you can actually give a clear difference between my data stream, my time series collect, for example, is about data aquifer ultimate feature of interest, but the proximate, the station was this one. This is for the green classes, the green addition. And the pink is the fact that in OMS, many things can be related. You can relate an observation to another one. You can relate a collection to another one. I mean, you get the drill. So we have a relation extension. We are best to be backward compatible as much as possible. And the good point is that SensorThings migration, to a 2.0 version that is OMS compliant was to happen anyway. So it's kind of the water quality he did the pre-work, and now it's being fitting the SensorThings 2.0 draft version. And now we are based on that. I guess no, it's written here in the slide. It's that schema that's being modeled, but it's also been implemented in Frost so that we can implement where. So we have different implementation exercise going on. We have the water quality IE members doing that. So there is I would say, North American node with USGS, USCPA data stream. We're doing it at BRGM as well. BAG in Germany is doing that for UNESCO GEMS Water database. Fraunhofer is doing that on some German data. And we have also a lot of other EU projects related to water where we are also involved. So Waterfall, I will mention that afterwards. So we have many projects running at the same time about the same topics. So it would be stupid to reinvent the wheel. So actually, we managed to convince people in Waterfall, so those I started to list, to also implement it. And the GSEU is a Geological Survey for Europe project partner. So many European Geological Survey are also investigating the use of it to share their groundwater data. Nice momentum. It's kind of not respecting the fact that OGC does not like to have a IE lasting so long, but we're producing content and we have a lot of implementation node, and actually it works. So these are a bunch of screenshots. This one on the left side is some data for surface water quality that comes from the Internet of Water in the US. So like these are nitrate Detroit, and this one is set of data between France and Germany. What next? We have to land the DIE. So we have planned to, we're still on the right track. I failed to have a demo at the member meeting in June. And then we'll have the classical sequence of doing the engineering report. And the engineering report, there is a high chance it looks like, or part of it will look like an update of the water now, part 5 water quality best practice update. And then the report might say we should update the best practice, and then we will submit the best practice formally for adoption and stuff like that. And if we think a bit next steps outside the IE itself, continue implementation. There is a line going on through WMO, World Meteorological Organization, where, for example, they try to embark people of the La Plata Basin in South America, the huge basin, to implement it as well. Add the other use cases. If you remember, biology was out scope, hydro models, remote sensing as well, because there are several projects, at least in Europe, I've been seeing, and some of them contacted us actually when we studied the IE, and we concluded together that those projects were on remote sensing, and we said, no, we cannot handle everything, maybe next steps. And there is a part we thought we could do, but then, I mean, time ran fast, even for long IE, is working on the shared control locales. Because if you look on the previous slide here, the observable properties, even if it has been nitrate on every or graph, it would have been written differently. So it's not, I mean, it's not aligned. So obviously, we should do that. This kind, I'm not sure it's part of real OGC actual work. I'm hoping somehow research activities like through RDA, so various research projects might have more leverage on aligning vocabs on that. So that's something we want to do as well. So I'm almost done. I will have just 3 slides remaining on the 2 projects research water projects that are actually contributing to the IE and other dynamics. The first one is One Water. That's a French research project. It's a 10-year research project, different challenges, and one is about actual fair water data exchange and setting up the corresponding platform. So I'm involved in that one, and I'm actually involved in both. But so this one is somehow the French node of the second one. The second one is a big partnership in Europe called Water4All. The figures here are just for the first 2 years. So huge envelope kind of partners, and it's even bigger for the second phase that started 1st of June. So there are also various elements. What is important to remember, it also targets fair water data exchange and setting up fair water data platform. So the shared element between both are the following. They are long-term projects that just start. They are both with a mixture of public organization and research data. They both want to apply those list of standards and best practices, and those we know quite well. And they both will work at sharing, the usual river networks, aquifer system and stuff. What is important as well is, in addition, the observation and monitoring system. So it rings the bell of the water quality and stuff like that. And we are starting, especially in Waterfall, to evoke other aspects that we've been less discussing, in the idle week, but like wastewater industry data, bathing stuff. We're discussing like with the EEA in Europe, for example, as well. So European Environmental Agency. So let's see where it goes. I do see those 2 projects as a nice opportunity to define or refine. I should have wrote that in the slides. The standards and the best practice for water, nice chance to update WaterML 2.0 line and enrich that maybe. Yeah, contribute to how to use those standards for the water community. I had a presentation as well for the hydro, so I'll get the link. And yeah, I'm not the yeah. If people are interested, we could actually add some more projects. And even, what is interesting is that on Waterfall there is a line for international cooperation. So even I don't know if there are contacts, for example, in Australia, for example, but there maybe the people we could link some project. Because I know, for example, that when I mentioned to the waterfall drivers the La Plata Basin in South America, trying to implement the water quality outputs for water quality in South America, they actually told me we do have link with Brazil, Argentina. So waterfall partners in a way, or collaboration network does not stop at Europe boundaries. So it's actually good to know. And I guess I'm done. Matt, you can.
That's good. Well, maybe on
Oh,
on that last one then, on your last slide, there's some.
You want me to roll back here?
No, so when you're working, you've got that could also share other types of data. Is it with organizations who are struggling to share their data, they're struggling with the technology, or is it there's a whole load of other, I mean, are they actually willing to share data? Are there issues in that area?
There are, for example, if we speak with the Danish environmental portal, they have decided way back to use observation measures as their cornerstone of their information system. For every observation you may have, so not only just river networks or aquifer systems, even like for industry, even for garbage collection systems and stuff like that. So if we do go back to water, we're scratching the surface of could we define jointly how we could share I mean, without discussing for that answer the difficulty or not to access data, but water abstraction by industrial plants or these kind of things. So conceptually, yes, we can. I mean, in France, we have a lot of models for that. There are some of the models that are done in the reportings for Europe as well. Many countries do have those things. So that there are opportunities to discuss that. Those type of how do we model, I don't know, like sewage system and exchange of their data. Modeling also, groundwater level modelings and this type of things. There is an interest in sharing that type of kind of like groundwater level forecast. We've seen drought or floods.
Yeah, we've got more examples of that.
So you want me to move to your slides?
Yeah, go on then. Well, it's just for us now, I guess. But yeah, and for the recording, it's just to note that, and I picked up something from your slides earlier. Yeah, we've got a new project where we're setting up, implementing some research catchment basins, but there are obviously lots of other stuff out there already. We've looked across some of those research catchment data set catchments and how they manage data, make data available. There's some kind of initiatives to kind of join up people doing research in those catchments and the kind of community around those experiments and those catchments, but I hadn't identified many activities actually looking at linking up the data from those, actually trying to see what you could do, but whether that's just general metadata about the kind of experiments or about the catchment types. But I noticed on one of your slides earlier, you're saying that the Oscar is involved in it's got the SensorThings API implementation, is that right?
Yeah, and actually Oscar is involved in the One Water project I mentioned, and Bjargen is provider of data in
Torino as well. Did you mention
well?
Torino? Okay,
yeah,
so you potentially have actually got some
connections
with who are actually making data available as well. So.
Yeah, and Oscar is actually building its pattern of data around SensorThings for the observation side.
So we've got this new well, it's like a research infrastructure we're calling it, but it's catchment. It's intensive monitoring over 3 catchments with a sort of related digital systems. We'll be looking at implementing, standard-based, data sharing, and the data models we're going to use, trying to start to include, all, as much we can around sensor information, sensor uncertainties, provenance information, that kind of things. It's just, I wondered whether there were even opportunities out there to link up data from these observatory networks, or whether it's still at the stage of even just finding out what observatories there are. So was optimistic. So it was hoping if there was a.
You want me to move to the next slide as well?
Yeah, and I think thought it might be more of interest for RDA as much as, the hydro DWIG is often the sort of national agencies. There's fewer research organizations, and I think the reach into those research organizations managing this kind of data isn't necessarily there, but it would be interesting to see that. So it's just, it was more kind of
there is a huge potential, but we need to find the nice way to engage with research networks, I would say, because like if we look at Water and Water, for example, we have the national French monitoring system, but then we start adding research infrastructure and initiatives, and at least I do have 3 or 4 coordinated activities in France that are not always under the same organization, or they are cross organization. They do monitor sometimes the same rivers, or there are local initiatives, and which at our humble level try to say, hey guys, can you just sit around the same table? You do actually have nice catchment definitions, station, the observation, the properties and stuff like that. It's just a matter of just using the same models.
Yeah. But I mean, integrating it into those national networks is one thing, just enhancing the representation of types, certain types of catchments, which are often missing, small catchments from those national data sets when it comes to kind of flood modeling and stuff.
Exactly, but I do feel the data and the will is there. It's just that people just are not aware of the fact that they could use just this model, this API, so they obviously reinvent locally their structure.
Yeah, well, I think they're kind of often sometimes, I was kind of the last bit about necessarily got the capacity to do the data, they manage the data for their local research community, but they don't necessarily have the capacity to set up technologies to integrate it and serve it up.
That's also something we embarked in both Water and Water4All is those projects are not exactly built the same way we built 10 years ago. Those type of similar projects, we added a lot more. It's not only the capacity building aspects, more the community aspect. Because usually before, like 10 years ago, we would have written like communication training, capacity building, like you provide cookbook and drop down. And what we try to do now is identify what's preventing people from actually not knowing that there is a standard that tool could be deployed and stuff like that. So it goes further than just a simple cookbook. We're just trying to
promotion almost.
Yeah. Trainings, and also we try and invest time and money into promoting open source solutions. Even the fact that like funding the fact that QGIS can ingest SensorThings, for example, we do feel it could help a better uptake of the approach. Because if you just release the PDF of the standard with no support in the tooling, I mean, there is fewer chance people use it. Okay.
Yeah, so it's just well, to be good to think about the forum, maybe not this one because
I don't know if it's a matter of forum or if it's a matter of time slot. That's the main worry.
Yeah, but other networks where there's more hydrology representation, more of these identifying how you get to talk to these groups doing this research monitoring and try and discuss.
I'm thinking, should we stop the recording
Yes.
before we analyze the section.
Yeah.
So thank you for people looking at the recording, and I will stop the recording.